Welcome to Science and Environment. Today we are going to discuss about capacitors. What are capacitors? Capacitors are energy storing devices available in many sizes and shapes. Its function is to store the electrical energy and give this energy again to the circuit when necessary. What is capacitance? To understand this, we are going to a thermal phenomenon. When we apply some heat to a material, here it is taken as a liquid form, the temperature of the material rises or increases. But when we take two different materials and giving the same amount of heat to them, then the temperature rise of the both are not equal. That is, if the temperature of rise of the first material is θ1 and that for the second material is θ2, then θ1 is not equal to θ2, because this depends on the thermal capacity of the material. Now we are going to electrical phenomena. When we give some positive charges to a metallic body, then its potential rises. But when we take two different materials of different shapes and sizes, if we give the same amount of positive charges, then their electric potential rises are not equal. If the potential rise of the one is V1 and that of another is V2, then V1 and V2 are not equal, and this depends on the electrical capacity, and this is called capacitance. The capacitance of a material depends on different factors which we shall discuss here. Now, what is capacitance? Capacitance is the ability of a component or circuit to collect and store energy in the form of an electrical charge. Simple explanation. Let us consider two bodies of different shapes and sizes. When you are giving a positive charge plus Q to one, then automatically another will get minus Q. A certain fraction of the flux of E originating from one conductor will terminate on the other, and the potential difference between the conductors can be calculated from the electric field between the conductors, and the relation is V equal to integration E dot dr with negative sign. But if we take different amount of charges, let us consider 2q charge and another minus 2q charge, then the potential difference should be 2v, that is, it is linearly related. If you take it 3q, then the potential difference should be 3v. So the potential difference is proportional to the charge given to the body. Now, there is a linear relationship between the charge and the potential difference. So Q proportional to V, here V is the potential difference and Q is the given amount of charge, then Q equal to CV, and this constant is called the capacitance of the system. Now you can define the capacitance as C equal to Q by V, that is the ratio of the charge to the increase in the potential. SI unit of capacitance is farad, and it can be defined as when V equal to 1, then the amount of charge required is the unit of capacitance. So farad is the coulomb. 1 coulomb by 1 volt is the farad, 1 farad. Now, the capacitance of a capacitor is the number that tells you how good that capacitor is at storing the charges. So the capacitor with a large capacitance will store a lot of charge, and a capacitor with a small capacitance will only store a little amount of charge. Capacitance depends on 3 factors: the area and shapes of the capacitor plates. You can take different type of capacitor plate. The area is a factor, and also the shape of the capacitor plate. Maybe it may be spherical, it may be cylindrical, etc. So upon that the capacitance depends. If the area increases, then the capacitance increases. Medium in between the plates of the capacitor. If the dielectric constant increases, in the dielectric constant between the plates increases, then the capacitance also increases. And also on the presence of any conductor near the capacitor, preferably that is grounded, then the capacitance also increases. Now, the process of charging a capacitor. When we connect a battery or power cell to a capacitor, then the plates, here it is taken as parallel plate capacitor, then the plates becomes charged. One is positively charged and the another is negatively charged. But how does it occur? Negative charges from one plate moves towards the positive end of the power cell, and from the negative end of the power cell the negative charges move towards the another plate of the capacitor. We can explain the phenomenon as shown in the figure. There are equal amount of positive and negative charges in a metal. That is it maintains the charge neutrality condition. But when we connect a power cell, and here the positive end is connected to the metallic plate, what happens? The negative charges move towards the positive end of the power cell, and this way the amount of positive charge increases in the plate, and the metallic plate becomes completely positively charged. What happens on the another plate? When it is connected to the negative end of the power cell, then the negative charges moves towards the plate. In this way, the positive and negative charges recombine. When they recombine, the residual charge are only the negative charges, that is electrons in the plate. So one plate becomes completely positively charged and the another becomes completely negatively charged. This is the way a capacitor is charged. Now we are going to calculate the energy of a capacitor. When a capacitor is not fully charged, then a small amount of positive and negativity is produced in the plate. We considering the intermediate stage during charging the plates. Here the small q amount of charge is given to the plates in the intermediate stage, and in this situation the potential difference between the plates is V, and we can write that V equal to Q by C, where C is the capacitance of the plate. Now, if we want to give some extra amount of charge, so work has to be done against the potential difference. So dW equal to VdQ, this is the work done, and V equal to Q by C. So the total amount of work done should be the integration of this. If the total amount of charge after full charge of the capacitor is capital Q, then the limit of the integration should be 0 to capital Q, and the answer is Q square by 2C. And if the potential drop across the capacitor is capital V when it is fully charged, then capital Q equal to CV, and we can write that the value work done, the value of the total work done equal to half CV square. And this work done is stored as the energy in the capacitor, and the energy of the capacitor is equal to then half CV square. Thanks for watching Science and Environment channel. Please like, share and subscribe. We shall discuss the next topics in the next videos.